Okay, let's hope you all can hear me. Thank you for attending this Perry Johnson Laboratory Accreditation webinar. We are going to be covering ISO/IEC 17025, section 7.8, covering reporting of results. I'm going to give another minute or so just to let any late joiners to join us, and then we'll start. So. Okay, I think we got pretty much everybody in, so I'm just going to start then. Again, like I said, we are covering ISO/IEC 17025, section 7.8. This is covering reporting of results. I am Michael Tomase. I'm a calibration calibration program specialist here at PJLabs. Yeah, let's just start. Let's see, there we go. Okay, so this webinar is being recorded, and the PJLA webinar recordings and slides are going to be available for download on our website. So there's the link right here. The past webinars are also up on there, and I believe all of those will be uploaded onto our YouTube channel as well. But you can go through that. If you look here at the bottom of the page, I've just copied over our the banner for the top of our website. And if you look here at the training spot, that'll give you a drop-down menu, and then you can go to past webinars and the rest, and you will be able to track that down. All attendees are muted, except for myself, obviously. However, if you feel, we do have a questions tab, so please feel free throughout the webinar to put your questions in there. And at the end of it, we have some time dedicated, and I will be going through those. Please try and keep those questions relevant to the topic of the webinar. I might try and answer some of the ones that aren't, but I also may decide not to. It's going to depend on what those are. I'm not necessarily prepared for some of the other topics, but we'll see what you guys post. Yeah, let's see. Okay, so section 7.8, again, like I've said a couple times now, is regarding reporting of results. This is the report that the laboratory will issue and is generally considered to be the final product. This usually is going to be either a calibration certificate, a test report, or other kind of reporting of result is what we're talking about with these. Now, ISO/IEC 17025, 2017 revision, is designed to ensure the factors that can affect this final product are addressed. So these can include, but are not limited to, that the personnel are properly trained. We want to make sure that the people performing the calibration or test or sampling know what they're doing, that the appropriate procedures and practices are in place, that there is a plan, a process that is laid out and in place for how they're going to perform the calibration, testing, or sampling, that those are appropriate to whatever test, calibration, sampling you are performing, because there are, God only knows how many different types. Let's see, that the facilities are suitable. So this can be either your laboratory itself or your mobile facility, or any other facility that you are performing the calibration or test or sampling in. That the equipment being utilized is fit for purpose. So basically that the equipment, the calibration standards, the testing equipment, whatever equipment that you're using for those activities, that it is designed and being used properly for whatever task it's being used for. That the standards have traceability, so that they are traceable back to the NIST or the SI, the International System of Units, of France, essentially. And then a process for handling the customer's equipment so that you are not damaging or in other ways harming the device under test or the other equipment that is being sent to you. That, of course, can have an effect on how the calibration or test, the outcome of the calibration or test, if it's damaged or mishandled. Okay, let's see. There are a few common names that we utilize, just industry-wide, for the documents that report the results of the calibration and tests. The most common ones are calibration certificate. That's going to be 9 times out of 10 for a calibration. It's going to be called a calibration certificate. A test report, again, that's basically the standard one for testing. There's going to be a test report of some kind, or a report of calibration. There are also any number of other ones that individual labs will call their work product, their reporting of results. But for the sake of this presentation, these are largely interchangeable. And again, the naming convention is determined by the individual lab. These are just the most common ones that you're going to find, and the most common ones I found throughout my career. So, but again, completely open to the individual lab. They'll throw you a curveball of what they're going to call the reports. So just be aware. Okay. Now, something to be aware of is there are accredited and non-accredited reports of results. So even if the laboratory is accredited, you want to be aware that some of these, not some, a lot of the labs that are accredited for calibration or testing, but specifically for calibration, since that is my background, they will also perform non-accredited calibrations. So you want to be very clear that you are getting, if you're trying to get an accredited calibration, that you are getting an accredited calibration. So when a calibration or test certificate or test report utilizes the accreditation symbol or references the accreditation, they will fall under the section 7.8 of ISO/IEC 17025 and any applicable policies of the accreditation body. So if you see their logo, like our logo in the bottom left here, that means on the calibration certificate or on the testing report, that means that it is, or they are presenting it as an accredited calibration. If they're making a claim that it is an accredited calibration, it is then going to be treated as such. If you are that lab, you want to make sure any non-accredited calibrations are not showing that logo or are making such claims, because that will get in trouble with the accrediting body, either ourselves or one of the other accreditation bodies. So just be aware. Now, PJLA's policy regarding this is SOP-3, the use of accreditation claims and symbols. Any of the other accreditation bodies will also have similar procedures or policy statements covering this. This is kind of a ILAC requirement, so you're going to see this no matter what, but ours is the SOP-3. And this gives specific guidance of what we're going to accept, what we're not going to accept, and how to utilize that. So just be aware that is also, again, freely available on our website. So it's going to be on our documents for that. So just be aware. And there they go into very specific aspects of that. But I wanted to make you guys aware of the accredited, non-accredited, because we do get issues with that during assessments of, well, I thought it was accredited. Well, best way to avoid this is to include the information that you want accredited on your purchase order, the quote, or other documentation when you're negotiating that with the lab that you're getting the equipment calibrated for or tested for. So just be aware. Okay, now section 7.8 itself, reporting results. This section covers 3 main areas for 17025: testing, calibration, and sampling. And it is divided into the following subsections. Now, testing is kind of obvious. Calibration, you're calibrating an item, a piece of equipment. Testing, you're testing an aspect of a physical item more often than not. You know, testing chemical, testing a, let's say the chemical composition of a piece of steel, or even testing the durability of something. If the testing is a very broad area, calibration is more specific. It's more a specific piece of equipment, you are making sure that it is calibrated and accurately giving you readings of whatever piece of equipment it is. And sampling is more narrow, but is usually more closely paired with testing. So just be aware. Now, the following subsections are 7.8.1 general. Again, it's generally this covers the review and authorization prior to the release of the results. So, and we're going to cover these specifically as we go. This is more just as an overview of all the sections that we're going to cover. So, 7.8.2, the common requirements for reports, the testing, calibration, and sampling. So that section 7.8.2, the requirements for those are the requirements for all. It is the universal requirements for any reporting of results, either testing, calibration, or sampling. Okay. Now, 7.8.3, specific requirements for test reports. These requirements are going to be on top of the ones outlined in 7.8.2. So keep that in mind. These are going to be specific for test reports, but on top of or as well as the 7.8.2 requirements. The 7.8.4 are specific requirements for the calibration certificates. Again, these are in addition to 7.8.2, but they are just for calibrations. So, and the calibration reporting, however you're reporting the results of the calibrations. So keep that in mind. 7.8.5, specific requirements for reporting sampling. Sampling is, again, usually paired with more with testing, but it is possible to have a calibration that covers sampling. But again, these requirements are going to be on top of the generalized requirements. 7.8.6, reporting statements of conformity. This is going to be more pass or fail, in tolerance, out of tolerance, that kind of statement. If you're making those statements, this is going to be the requirements thereof and how those are necessary to be utilized. 7.8.7, reporting opinions and interpretations. Pretty straightforward. If you're reporting an opinion or an interpretation of the data, how that is going to be reported, the requirements therein, and etc. 7.8.8, amendments to the report. So if you messed something up or made a mistake and you need to amend the report, that is the requirements therein and how you're going to be able to do that. What's going to need to be on there, naming conventions, etc. So those are all the sections or subsections for 7.8 that we're going to cover just today. Now, section 7.8.1, reviewing and authorizing results. 7.8.1.1, the results shall be reviewed and authorized prior to release. Now, every time you're going to see a shall here, I tried to bold all of them. Shall is very particular to 17.025. There's I believe a separate section at the beginning of 17.025 that underlines and denotes that shall is, it will be, it must be, it is a requirement therein. So just keep that in mind. Anytime you see in the standard that it says something shall be done, it means it is a requirement that it must be done. So they need to be, the reports need to be reviewed and authorized prior to release. Who reviews those, authorizes those results? That is open to the individual lab. You could have, generally it's going to be the lab manager, the quality assurance manager, but it could be anyone. It really is going to be what you put into your procedures or quality manual. So, but the main thing is that you have to have somebody review them and authorize them, and then be authorized to review them. Section 6.2.5 also covers into this area. There's some overlap because this section overlaps with the previous requirement of 7.8.1.1. I'm including a couple of those sections here. 6.2.5, laboratory shall have procedures and retain records for, and section echo of that, it lists a bunch of other things, but for the sake of this webinar, authorization of personnel, section E. So laboratory shall have a procedure and retain records for the authorization of personnel. Again, there are a number of different ways you can maintain that record. That's going to be largely open to yourself and to the lab. And section 6.2.6, laboratory shall, and again, shall authorize personnel to perform specific laboratory activities, including but not limited to the following. And section C of that is report, review, and authorization of results. So not only does somebody have to review and authorize the release of that report or the results, you also need to have a document in some way authorizing that person to perform those reviews and authorize the release of the reports. So again, there's a million and one different ways the various labs do this. Could be anything from each individual employee, you're going to have their authorization for what they're capable of doing, or you could have a Excel document where you're just listing what they're authorized to perform. This is going to be one of those things that they're going to need to have authorization for. So, and documentation that they are authorized. So keep that in mind. Okay, section 7.8.1.2. The results shall be provided accurately, clearly, unambiguously, and objectively. This is important that those are met, usually in a report, e.g. a test report or a calibration certificate or a report of sampling. As we discussed previously, there's any number of names for these reports. And shall include all information agreed with the customer and necessary for the interpretation of the results and all information required by the method used. All issued reports shall be retained as technical records. So again, you need to retain your reports, your calibration certificates, etc. Anything that you're issuing like that, reporting the results, you need to retain those records as technical records. And it shall include all the information agreed with the customer and necessary for the interpretation of the results. So any information, if you get simplified reporting and the customer wants simplified reporting, you can leave out some information. But again, the customer has to agree with that. But any information that is needed for the interpretation of the results, the raw data, etc., that needs to be included. You don't necessarily have to show the equations and whatnot, but you need to show the data that they're going to be used in order to get to the answer, the results that you're presenting as the results. And again, unambiguously, that means not open to more than one interpretation. It has to be clear, unambiguous. Objectively is defined as in a way that is not influenced by personal feelings or opinions. A lot of times you're dealing with pretty straightforward math. Math does not lie. It is objective and unambiguous. The unambiguous, clear, and accurate part of that goes back in large part to the handwritten reports. A lot of times now it's printed, but you want to make sure that it is clearly legible, unambiguous. You're not going to mistake that 6 for a 9 or that 0 for an O. Stuff like that. You're going to want to make sure that is very clear. And so that the client and anybody who's looking at that certificate, that test report, is not going to misinterpret that. So that is the purpose of this section here. Okay. And we got a little dragnet thing of just the facts, ma'am, just the facts. There are 2 notes for this section. Note 1, for the purposes of this document, test reports and calibration certificates are sometimes referred to as test certificates and calibration reports respectively. If you are a laboratory performing both testing and calibration, it's always a good idea to have the 2 different titles just so it doesn't get mixed up. But again, that's just more determining the different terminology being utilized for these reporting of results. Note number 2, reports can be issued as hard copies or by electronic means, provided that the requirements of this document are met. So that's right, boys and girls. ISO 17025 is finally in the digital age. We are allowing both paper and digital copies to be used. Usually the go-to is a PDF if you're doing digital, just so they can't alter any of it, but there is no specific requirements here. And you could do both as well. I see that quite often of they'll mail the physical copy and they'll email the digital, but that is up to you and your customer of which ones they prefer. So just keep that in mind. You do have that option now. I think the older revision was very specific of the physical copy, but so, okay. 7.8.1.3, and this area governs the simplified reporting that I briefly mentioned before. When agreed with the customer, again, the customer has to agree to this. This is outside of the norms. The results may be reported in a simplified way. Any information listed in 7.8.2 through 7.8.7 that is not reported to the customer shall be readily available. So even if you are simplifying the report, like you're not including all the information, you still need to maintain that information so that if you are asked, you can provide that. So let's say they want a simplified reporting of just the pass-fail. You can provide that, but you still need to have the raw data in order to be able to get to the results that you're showing. So keep that in mind. A record of these agreements should be maintained by the lab. So you're going to want to have some written agreement that, hey, the client is okay with you giving them simplified reporting. Generally, what I've seen is this is included as part of the quote or purchase order or contract. As that is negotiated, you'll have that in the fine print. You'll have that in some point there where they're agreeing to it. And then you can just use that as that aspect, that requirement. Records need to be maintained where, if needed, all requirements under reporting can be retrieved. And again, what that means is anything that is necessary to come to the results that you are reporting, you need to have that information maintained and documented and kept so that if they want the full report later, you can provide that. You may charge them extra for it, but you are capable of providing that without additional work because you have that data. And PL-3, this is PJLA's policy or procedure, specifies the written agreement regarding the uncertainty reporting. So if the simplified reporting is excluding the uncertainty reporting, PL-3 is going to specify the requirements. Specifies that a written agreement is necessary for that as well. So keep that in mind. Okay. Okay, now we're in 7.8.2, the common requirements for reports, testing, tests, calibration, and or sampling. All right. So again, these are the requirements that are going to be for any of the reports of reporting of the results. So this applies to all of them, testing, sampling, and calibration. 7.8.2.1, each report shall include, again, I'm gonna keep underlining that because it's very important, at least the following information, unless the laboratory has a valid reason. And again, I'm bolding that because there is possibilities where you're gonna have a valid reason for not doing so. Thereby minimizing any possibility of misunderstanding or misuse. So if you have a valid reason the valid reason is going to have to be essentially it's minimizing any possibility of misunderstanding or misuse. Otherwise, you're going to want to include all of these. So all of the items that we're going to list here. So, okay, section A, a title. So this is literally, you're going to have somewhere on your certificate or test report, calibration certificate, or report of sampling. You're going to have one of those. What that specific name is going to be or title, that's up to you guys. That's up to your lab. Those are the three most common ones, but just be aware. You're going to have that somewhere on there, so it's not going to be confused with anything else. B, the name and address of the laboratory. This is generally going to be the name and address that is on your certificate and scope of accreditation. That's what they're meaning. You might have additional locations on your or locations or sites that is under the same scope or certificate, but there's going to be one primary one. That's what they're talking about. So, and that includes both the name and the address, the name of your company and the address of that primary location of the laboratory. And the reason why I'm going through that is because the next couple are going to give you a good reason why I'm differentiating between those. C, the location of the performance of the laboratory activities, including when performed at a customer facility or at sites away from the laboratory's permanent facilities or in associated temporary or mobile facilities. So this one is less relevant if you're only performing calibrations in your lab, on your facility. You're a single site laboratory, and all calibrations are performed in your lab. This is going to be less relevant. But if you're performing calibrations or tests outside in the field at the client's location, let's say, that address is going to be wanted on there. If you're performing it in a mobile facility, you're going to want to have some indication of it was performed in the mobile facility on your test report, on your calibration certificate. If it's in a separate, let's say you have multiple facilities, multiple sites, you're going to want to include which site you're performing the calibration or test. But again, it's going to be for the larger companies, this might be a bigger thing. For the ones that perform field work, this is going to be a bigger thing. If you're just a small lab and you only perform it in your lab, this is going to be less relevant to you. Section D, unique identification, that all its components are recognized as a portion of a complete report and a clear identification of the end. So this is largely shown as a certificate number, a report ID number, test number, whatever you want to call it. But it needs to be, you need to have a unique identification for each certificate or test report or whatever. Generally, that's going to be a number that you're just going to have. It's going to be, 000012, and then you'll just keep every sequential calibration or test. You're just going to move on to the next number, but it needs to be unique. You can't have them, multiple ones with the same number. It cannot be duplicated. The other thing that you're going to want to, the other portion of this requirement that you're going to want to be clear is clear indication of the end. The easiest way I found for this, and this is fairly common, is you have at the bottom of the page or wherever, you have a page 1 of 2 or 1 of 1 or whatever. You're going to want to show that there is not any confusion, that it looks like there should be something on the next page, but there is no next page. That's what that's trying to avoid, that you have the complete report, that it is. There are other ways to do that, but that I think is the easiest way. If you are only doing single page reports, you can have one of, this is the entirety of your report. It's going to vary a lot, but something that determines the identification of the end of the report, the complete, that you have the whole report, essentially is what we're looking for. Section E, the name and contact information of the customer. Now, the name of the customer, that's, you're going to want that on there. But the thing that a lot of labs miss is the contact information. Generally, that is going to be their address, because you're going to be mailing, say if you need to mail something to them, you have their address. I suppose it could be the phone number, but I've never seen anybody use that. But generally, you're going to want to have the name and address of the client, the customer, on your calibration certificate or test report. So keep that in mind. That is something that is a very common thing that people miss. F, identification of the method used. Now this can be anything from an internal procedure, a standard procedure like an ASTM, ASME, NIST, ISO. One of the common ones, if you're doing scales or weights, is the NIST handbook, I think 44. But again, that's the outside organization. They'll have their own method or procedure in place that you're utilizing, or a USB type method. I believe the USPs are for governmental or military or like, that is kind of going to be more based around your client and whatnot. But it doesn't have to be your own procedure. It can be an outside one agreed by the client that you're following. So just keep that in mind. Or an outside standard from an independent agency like ASTM or ASME or NIST or ISO or any of the other ones with a series of letters as their name. Okay, section G, a description, unambiguous identification, and when necessary, the condition of the item. So what was being calibrated or tested? So example, a truck scale or a glass thermometer or mass flow meter, you're going to have some indication of what you're actually calibrating or testing, or wheat seeds. It's going to vary a lot on what you're talking about, because what you can cover with 17025 varies a lot. It's a very wide standard, but some way to describe and be unambiguously identify what you are calibrating or testing. So H, the date of the receipt, the date of receipt of the test or calibration item or items, and the date of sampling where this is critical to the validity and application of the results. If you're not doing sampling, you don't need to include a date of sampling. It is only applicable for if you are performing a sampling, or if you're testing or calibrating an item that has been sampled. So, and that's only if it is going to affect the validity of the results. Even if you're doing sampling, it's not going to affect it. Then you don't have to include it. But if it is going to affect it, let's say you have seeds and they have a shelf life, or chemicals, or a water sample, all of that could affect the validity or the results in some way. So you're going to want to include that. But if you're sampling a box of screws, it's not really going to affect it too much as long as they're stored properly. So, but again, more broadly, the receipt of the test or calibration item, when you received it, when it came into your possession, when you opened up the box that got delivered to your shipping bay, you're going to want to have a date there of when you got it. A lot of times it's going to be the same date that you're going to perform the calibration, but you want to make sure and be aware that this is a separate requirement. Section I almost missed that one. The dates of performance of the laboratory activity. So when did you perform the calibration or test? You're going to want to include that on there. Section J, the date of issue of the report. Now, again, a lot of times you're going to issue the report the same day that you perform the calibration or test, right? But even if the date of calibration / test and the date of issue are the same, both need to appear. So there are going to be two different requirements there. So keep that in mind. That is one that is very common. They'll just be like, oh, well, we issue it the same day that we calibrated it. Still need to make sure that is some way indicated. Both of those dates, even if they're the same, you can have, but they need to have indication that is the case. Section K, reference to the sampling plan and sampling method used by the laboratory or other bodies where these are relevant to the validity or application of the results. Again, if you're doing calibration, 9 times out of 10, that's not going to be an issue. You're not doing sampling, so you don't need to include that. But if you are doing a sampling, you're going to have to include the plan and the method that you are utilizing with the sampling for, where these are relevant to the validity or application of the results. So if either of those do not affect the validity of the results or the results at all, you don't have to include it. But again, be careful. If they do, you do need to include that there. So it gives you some wiggle room, but be very clear of when you need to include that and not. Okay. Section L. A statement to the effect that the results relate only to the items tested, calibrated, or sampled. So that basically that they're only applying to the item that you're calibrating or testing, that they don't apply to anything outside of that. This is generally just going to be a simple sentence on your calibration certificate or test report. There's generally going to be a couple different statements that you're going to need to require to be on there. This is one of them. Literally, you just have a sentence that says the results relate only to the items being tested, or calibrated, or sampled, or whatever the case may be for what you're doing. Literally, that's all we're looking for. And section M, the results with, where appropriate, the units of measurement. So you're including the results of the calibration test or sampling. So the raw data of, okay, the meter read it was 5 degrees Celsius on the meter. There you go. You're including along with the unit of measurement, whatever that unit of measurement may be. So we got the standard ones, but but it can be the imperial units. You could have Celsius or Fahrenheit, but you're going to want the results to be in the same unit of measurement. So just keep that in mind. You're going to want to include the unit of measurement that you're using for it. Okay, section N, additions to, deviations, or exclusions from the method. So if you have to act outside of the method or the procedure that you're performing that calibration or test on or sampling, you're going to have to note how you deviated from that, how you, if you didn't do step 12, that is a requirement on the procedure, you're going to have to make a note that you did not follow step 12, or, you know, this was not, step 13 was not applicable. It's just going to have to be included in some way on that test report or calibration certificate, right? So that the customer knows that you have a record of it. We already did N. Section O, identification of the person or persons authorizing the report. Again, just you have to have somebody authorize it, and that person needs to be identified on the certificate or test report. Generally, what I've found works real well is you just have them sign there, or their name has to be on there somewhere that they authorize it. A nice little way to meet this with the date it was authorized is you just have them sign and date. You got their name, you got when it was authorized, done. But then you can do it any number of different ways. But the name of the person authorizing the report needs to be on that, and identifying that they are the one authorizing the report. This needs to be specified even if the same person performing the calibration and test is the person authorizing the calibration and test report. So some of the smaller labs, you only have one-man shops. Ideally, you're going to want somebody else, but if you don't have that option, you need to have a separate line saying that, you know, Bob authorized it as well as performed it. So just keep that in mind. Section P, clear identification when the results are from external providers. Now, this is governing if you are, let's say it's the item that they want calibrated through you, it's not in your scope, and you send it out to an external provider. You're going to want to have a clear indication that you did not perform this calibration, that it was performed by somebody outside of your accreditation or certification. Well, accreditation under 17025. But clearly identify that it was performed by, you know, ABC lab instead of, you know, XYZ lab, your lab. So just clear, so there isn't any confusion with that. Let me take a drink real quick. Okay. Note, including a statement specifying that the report shall not be reproduced except in full without approval of the laboratory can provide assurance that parts of the report are not taken out of context. So what this is trying to prevent is people copying and pasting or cutting and pasting part of your calibration certificate or test report and then sending that around. So again, you could just have a statement specifying that because with just, you know, a small section of it, you could be misinterpreting what the whole report says. So we want to avoid that. So having that statement is given as an option in order to help prevent that. It's probably the easiest way to do that. So just be aware. Okay, 7.8.2.2. The laboratory shall, and again, shall be responsible for all information provided in the report. So the lab is responsible for that report and any information therein. Keep that in mind. Except, and this is the exception, when information is provided by the customer. So sometimes the customer is going to provide you information for that. This could be anything from they sampled the item that you're testing. So that is some information that is provided by the customer. You did not have that. They just gave you the sample to test. It could be any number of things, but any time that information is provided that you are not responsible for that, the customer is going to be responsible for that, obviously. Data provided by a customer shall be clearly identified. That's pretty straightforward. In addition, a disclaimer shall be put on the report when the information is supplied by the customer and can affect the validity of the results. So if the customer is providing some information that could affect how valid the results are, you need to put a disclaimer on that report or that certificate, the calibration certificate. So let's see. Where the laboratory has not been responsible for the sampling stage, e.g., the sample has been provided by the customer, it shall state in the report that the sample, say in the report that the results apply to the sample as received. So again, like I mentioned above, I kind of got ahead of myself. If one of the common ones is the customer providing performing the sampling, you just need a statement in there in the report or a certificate stating that the results apply to the sample as received. So in order to, that gives you some wiggle room, it gives you some protection, and clearly states that you are not responsible for it, essentially. This is what that's doing. Information provided by the customer may be needed to proceed with the calibration/test if environmental criteria are not within the predefined limits, customer's location. So if you're performing a calibration or test at the customer's location and the normal environmental criteria, this is commonly temperature or humidity, are not within the predefined limits, they're not into your normal requirements of a lab, because you're performing it off-site at the client's location, you may need information provided by the customer. So just keep that in mind. That is a potential necessity, let's say. Okay, 7.8.3.1. This is 7.8.3 is the specific requirements for test reports. So this is, again, on top of the previous requirements for test reports, only for testing. Keep that in mind. So 7.8.3.1, in addition to the requirements listed in 7.8.2, test reports shall, where necessary for the interpretation of the test results, include the following. So again, you have an out, because there's a wide swath of different types of testing that you're going to perform. So if the requirement is not necessary, is not deemed necessary for the interpretation of the test results, you don't necessarily have to include it. You might be questioned on it if there's an assessment or an audit. They might ask you, why didn't you include this? And you were going to have to give an explanation and a reason for it. But if you have a good one, the assessor or the auditor, hopefully, will be like, oh, okay, and check the box that they need to check for you. So just be aware that gives you a lot of wiggle room, because there's a whole mess of different types of tests that are going to be performed. Okay, section A, information on specific test conditions, such as environmental conditions. So environmental conditions generally are going to be temperature, humidity. The other very common one, although this may be more for calibrations, is like atmospheric pressure or barometric pressure. But there could be any other environmental conditions that are relevant to the individual test, so keep that in mind. B, where relevant, a statement of conformity with the requirements or specifications. And again, it's directing you to see section 7.8.6, which is going to go more into that specific requirements. A statement of conformity is, you're generally going to be termed as either a pass or fail, or intolerance or out of tolerance. For testing, it's going to be generally pass or fail is the most common terminology, but it could be other terminology could be utilized, so just be aware. Okay, section C, where applicable. Again, this even gives you where this applies. The measurement uncertainty presented in the same unit as that of the measurand, or in the term relative to the measurand, e.g. percentage or percent, when it is relevant to the validity or application of the test result. So when it actually will affect the test results or the validity of the test results, you need to include that. And that means the same unit of measurement. So if it's in Fahrenheit, the measurement uncertainty should be in Fahrenheit. If it's in grams, it should be in grams. The exception to this is a percentage. So if it's a percent of reading, That's perfectly fine too. Does not need to be in the units of measurement because it is in percent of whatever the reading is. So you're good there. Or let's see, a customer's instructions so requires. So if the customer requires it, pretty straightforward there. The measurement uncertainty affects conformity to a specification limit. So if the uncertainty is going to affect the ability for you to meet a specification limit, then you need to include it. If it's not, then you don't necessarily have to include it. But under these three requirements or criteria, then you're going to need to apply it where it's applicable. So you the where applicable gives you even more wiggle room than the additional statement, the rest of the statement itself. So just be aware. This is just for testing. Calibration, you're probably going to want to include the measurement uncertainty. But for testing, there's a lot of different types of tests. So they give you a lot of wiggle room for this section. So section F, where appropriate, again, where appropriate, opinions and interpretations. And again, it directs you to 7.8.7. That's going to go into more specifics, but again, where it is appropriate, you need to include that. Section G, additional information that may be required by specific methods, authorities, customers, or groups of customers. So if, let's say, you have a state requirement, you know, or a government agency, the customer, group of customer, a specific method, if they need additional information because it's a requirement by the, let's say, the FDA or the Food and Drug Administration or Department of Agriculture has specific requirements and information that's going to be included there. You're going to want to include it on there. The customer will likely make sure that you're going to want to include that on there because that's what they're using it for. So just be aware. Section 7.8.3.2, where the laboratory is responsible for the sampling activity. Again, where the laboratory is responsible, not the client. Test reports shall meet the requirements listed in 7.8.5 where necessary for the interpretation of test results. So again, this gives you a whole lot of wiggle room of when you are performing the sampling, you need to conform with the 7.8.5 is that is the section of 7.8 that governs sampling. So it's just covering your bases there. But even that is only where necessary for the interpretation of test results. So even more wiggle room there. But this would apply when the laboratory is collecting the samples to be tested. If the customer or client is collecting the sample, don't have to worry about that part of it. So just keep that in mind. 7.8.4.1. In addition to the requirements listed in 7.8.2, calibration certificates shall include the following. So 7.8.4, this entire subsection is going to be governing the calibration certificates. This is in addition to the 7.8.2. You are not going to have to require for the 7.8.3, the one that we just covered. This is just for calibration certificates, not for test reports, not for sampling. So keep that in mind. Okay, section A, the measurement uncertainty of the measurement results presented in the same unit as that of the measurand or in a term relative to the measurand, e.g. percent. So like I mentioned with the testing reports, except without the wiggle room, because calibration, you need to include the measurement uncertainty in the same units as whatever units you're utilizing. So if you're measuring in grams, it needs to be in grams. If you're measuring in Fahrenheit, it needs to be in Fahrenheit. You can't have it in Celsius. It needs to be in Fahrenheit or at a percentage of the data. So if it's percent of reading, great, you're good. But you need to include it on there. Note, according to the ISO/IEC Guide 99, a measurement result is generally expressed as a single measured quantity value, including unit of measurement and a measurement uncertainty. So generally you're going to have, let's say, 5 grams. There you got the 5 is the unit, is the measurement quantity value. The unit of measurement is grams, and a measurement uncertainty plus or minus 3 grams, right? or plus or minus a gram, let's say. That's probably better. That's generally how you're going to see the data. So, okay. Okay. Section B, again, I'm just included at the top here. The calibration certificates shall include the following. Section B is the conditions, e.g. environmental, under which the calibrations were made that have an influence on the measurement results. Almost universally, this is going to be temperature and humidity or relative humidity, temp or RH. Some of the types of calibrations, you're going to want to include the atmospheric pressure as well, because that can sometimes have an effect, but it's going to depend on what calibration you're doing. But almost always you're going to see temperature and humidity. There might also be some other ones, but I've only really seen those three. There could be other environmental conditions that could affect this. So just keep that in mind, but that's going to vary a lot based on the test that you're performing or the calibration that you're performing. Okay. Section C, a statement identifying how the measurements are meteorologically traceable. See Annex A. Annex A goes into some more specifics about traceability. Also keep in mind PJLA's PL-2 governs our traceability policy. So that is measurement traceability policy. Okay, and that provides some additional guidance with that. As a general rule, I'll go over some basics of it right now. That means that it's going to be traceable to the SI, the International System of Units, right? It's SI instead of IS is because it's French. So I believe that's the reason for that, and just to avoid confusion with is. So now, one of the common things that we see on calibration certificates, and we're trying to weed this out as we go, as we're performing assessments. You used to see this a lot, you're still seeing it some, is they'll have a statement that the calibration is NIST traceable, NIST. Now, NIST is the, how do I put this? The United States' national laboratory. The National Institute of Standards and Technology. That's what that stands for. But the reason why we're bringing it up here is there are other national laboratories for individual nations or groups of nations. I believe there's a couple European Union ones that does it for the some of the smaller countries over in Europe, but that's going to vary. So there are other institutions that would be called a national lab or national standards Bureau or some other such. The NIST is just the United States one, so that's the one you're going to see most if you guys are in the US, but you might see traceable to a different lab. We don't want that language is termed as incorrect. In PL-2, I believe it has a subsection that goes into this and provides a alternative, a sample statement of what we're trying to provide. What we're trying to get everybody to switch to is traceable to SI through NIST or through whatever national lab you're using it for our international attendees here. So because the SI is the top of the pyramid, the SI is the end point of all of these calibrations. So if you look at the pyramid, you've got industry testing or calibration labs. This is going to be the manufacturing and whatnot, right? Then you have the accredited calibration laboratories. This is probably going to be you guys, the ones that are 17025 accredited, right? You're going to have slightly better equipment, or well, more than slightly, hopefully, better equipment than the regular testing or industry labs, right? Manufacturing side. They're going to send their equipment to you to get calibrated. You're going to send your equipment to either other accredited calibration laboratories, but then eventually they're going to send that over to NIST or whatever national laboratories you're dealing with if you're outside of the US. And then they are traceable back over to the SI. So that is, for weights, I think it is still a artifact. There's a physical gram or kilogram. I know that they're transitioning a lot of this over into the, what is it called? Like the Planck scale or the constant. So they're switching over to a bunch of constants that are more mathematically based rather than a physical artifact. Because there used to be, they're phasing this out, but there used to be like a physical block of, I think, platinum over in France that is the gram or kilogram or whichever unit. And it is a physical artifact. They're moving away from that in a lot of other how do I put this? Types of calibrations or units of measurement. So like, I know temperature, I think, is based on the Planck scale now. This was recently changed over, so just keep that in mind. But everything, all your calibrations are going to go up the pyramid. They're going to be traceable to NIST, then traceable to SI. So keep that in mind. Okay, section D. The results before and after any adjustment or repair, if available. So this is commonly shown as found or as left data. So let's say you are calibrating a piece of equipment and then you adjust it. After you adjust it, you're going to want to, it was reading outside of specification. So you adjusted it. Sometimes there's just a little knob that you twist to tweak it a little bit. And then you recalibrate it. That's the as left data. You're going to want to include both sets of data. If it came in damaged, or you found it that there was some damage while you were doing the calibration or before you were doing the calibration, that would also be the same case of the as found as left data. Both sets of data you're going to want to include. If it's already damaged, as found data might be NA, but you're going to want to have some documentation that yes, it was repaired or adjusted. Okay, section E, where relevant, a statement of conformity with requirements or specifications. And again, this is directing you more towards the 7.8.6 because that is the section that's going to cover more the statements of conformity. But this is commonly seen as a pass or a fail, in tolerance or out of tolerance, or some other similar phrasing of it. Again, pass and fail seems to be the most common, but intolerance and out of tolerance is also fairly common. Section F, where appropriate. Again, where appropriate, opinions and interpretations. Again, it directs you to 7.8.7 because that is the section that is going to cover more specifics of the requirements therein. And again, you have for section E, you do have a where relevant. So if a statement of conformity is not relevant, you have an out there, you have some wiggle room. Keep that in mind. Some clients or some customers may just want the raw data. They don't want a statement of conformity. It's perfectly fine. But again, you're going to want to have where relevant. So if the customer requests it, that's relevant. That's, then you don't need to include it. So just keep that in mind. Okay, 7.8.4.2, where the laboratories is responsible for the sampling activity. Calibration certificates shall meet the requirements listed in 7.8.5, where necessary for the interpretation of calibration results. Again, this is a similar one to the requirement listed in the testing section, 7.8.3. As a general rule, you're not really going to see much sampling when it comes to calibration. It just doesn't really apply. It might apply. I have not seen one where it applies, but hey, there may be some chemical testing or chemical calibration that requires it, but the sampling is primarily going to apply to the testing side of it. But if you are doing sampling, you need to follow the sampling requirements in the next section. So keep that in mind. Okay, section 7.8.4.3. A calibration certificate or calibration label shall not, this is one of the few shall nots, contain any recommendation on the calibration interval, except where this has been agreed with the customer. So this is one that is very commonly people get tagged on for during an assessment. You cannot make a recommendation for a calibration interval. So generally one of the more common ones is an annual calibration interval. You can't make a recommendation for that. The client has to agree or agree to whatever calibration interval you're putting on your certificate, you're putting on a calibration sticker. A lot of times, a lot of the labs will put a sticker on the calibration certificate, kind of like what is shown below here. But you cannot have the next cal do part filled in unless the customer agrees. Generally, that's going to be included. The easiest way to do that is to include some a line, a sentence or two in the quote or the purchase order or some other documentation of that, and then or they might request a specific calibration interval. This is really up to them, but you cannot automatically default to one. They have to agree to it. So just keep that in mind. Okay, 7.8.5. This is the subsection governing sampling. So again, sampling is generally a testing thing. It can be a part of testing, not always though. So 7.8.5, reporting sampling, the specific requirements. Where the laboratory is responsible for the sampling activity, in addition to the requirements listed in 7.8.2, those generalized requirements we did a while back. Reports shall include the following. Again, and you got a little exemption here, where necessary for the interpretation of results. Again, like testing, sampling, there is a lot of different types of sampling that you're going to be doing. So it gives you some wiggle room here for these requirements. But you might have to defend them to an assessor and explain them to a client or whatever if you're not including these. So just be aware. Okay, A, date of the sampling. Pretty straightforward. When did you take the sample, or when was the sample taken? You want to include that on the report. Section B, unique identification of the item or material sample, including the name of the manufacturer, model, or type of designation and serial numbers as appropriate. So if you're doing a sample of a box of screws, like so you're not going to test every screw in the box because there's 1,000 of them, and that's just going to take you a week. You're going to do a sample of them. You're going to want to list the manufacturer, the model, maybe the serial number if there's one there, or some other designation. That's going to vary a lot on what you're sampling. So just keep that in mind. And then again, you have that as appropriate. So if it doesn't have a serial number, that's that's your explanation. It didn't have a serial number, so you're good. But all right. C, location of sampling, including any diagrams, sketches, or photographs. This is going to be more relevant for like, let's say you're doing a water sampling of a pond, a lake, or you're going to have a map, and you're going to want to have the locations of where you took what sample marked on there. If you are doing, let's say you are testing a whole bunch of bags of seeds, right? You're going to be taking samples from different portions of the bag or sack or whatever of seeds. You're going to have a sketch that's going to show we took it from the top left corner there, we took it from the middle, we took it from wherever you're taking the samples from. This can be a diagram, a sketch, or a photograph, but you're going to want to show in some way, especially because that could affect the, especially if that could affect the validity of the results in some way. So keep that in mind. Section D, a reference to the sampling plan and sampling method. So what method are you doing to perform the sampling, or what plan are you doing? This could be, there's a whole bunch of different methods and plans that are available to you. You're just going to want to list and include that. And that could be either an internally developed one or externally developed one. Just keep that in mind. Section E, details of any environmental conditions during sampling that affect the interpretation of the results. So let's say again, you're testing the water in a pond. The water temperature could have an effect on the sampling, on the sample itself that you took. Any environmental conditions that could affect that, you're going to want to document and maintain and include on the sampling report in somewhere. If it's not going to affect it, then you don't have to. But if it does, you should include it. Again, there's a lot of variance because of the different types of testing that you're going to be that could be performed. F, information required to evaluate measurement uncertainty for subsequent testing or calibration. Again, this is less likely to be relevant because measurement uncertainty tends to be more for calibration than for testing, but there are instances where it could be applicable. So just keep that in mind. If that does apply, you're going to want to include that in there. The test is going to be, is it going to affect is it going to be required for subsequent testing or calibration? So if it's going to be necessary for future testing, then you're going to want to include it in there. Okay, now 7.8.6 governs the statements of conformity. So let me take a drink. Okay, so 7.8.6.1, when a statement of conformity to a specification or standard is provided, the laboratory shall document the decision rule employed, taking into account the level of risk such as false acceptance, false reject, and statistical assumptions associated with the decision rule employed, and apply the decision rule. So we're going to go into more specifics on, I talk about this later, the false accept and false reject and what those entail. So just keep that in mind. But essentially, when you are having a statement of conformity, you aren't necessarily, if you're not doing a pass-fail or in tolerance, out of tolerance, this isn't going to apply. But when you are, this was going to apply. You shall, it's a requirement, say which decision rule you are employing, which one you're using, and taking into account the level of risks associated with the decision rule that you're using, and how you're applying the decision rule. Note, where the decision rule is prescribed by the customer, regulations, or normative documents, a further consideration of the level of risk is not necessary. So we'll go into this a little bit later as well, but there are certain ones like the ASTM or ASMI where you'll have outside methods or procedures that take this into account. They take the decision rule as already baked into that. It's a part of that. And it is going to factor in all of that outside organization that you're using for. That's going to take on the responsibility of addressing those levels of risks. So that gives you a nice little out there, but just be aware that is for those instances. ISO/IEC 17025 defines decision rule as a rule that describes how measurement uncertainty is accounted for when stating conformity with a specified requirement. So this is actually in 17025, the definition section at the top, at the beginning of it. So just there you go. That's how we're defining that for this section here. It's just a useful understanding. Okay. 7.8.6.2. The laboratory shall report on the statement of conformity such that the statement clearly identifies, and the following is, A, to which results the statement of conformity applies. So if you have a single point of calibration, that's not going to be all that difficult. If you're having 5 points of calibration, it's going to be clearly identified which point is passing, which point is failing, etc. And which the statement of conformity applies to which. B, which specification standards or parts thereof are met or not met. So if the specification standard or any part of those are being met or not being met, if it's meeting up to the ASME standard, there you go. Or what particular part of it is not meeting that. You're going to want to specify. C, the decision rule applied unless it is inherent to the requested specification or standard. Like I talked about before, some of the decision rules are baked into the, let's say, ASME, American Society of Mechanical Engineers, I think that is, or another similar organization that has that already baked in. You're good. Otherwise, you need to have which decision rule you're applying. Okay. So note, for further information, see ISO/IEC Guide 98-4. So there's a ISO guide that provides some additional information with regards to the statement of conformity. That should give you some place deeper to dive into if you want to go more in depth there. So, okay, so this is the part where I was describing before. Let me, because I'm gonna need the, I'll have a spotlight here. So this is, I got some diagrams here showing the how the statement of conformity is going to factor in the uncertainty, right? So this can get a little more complicated. So I thought the best way to show this is with these diagrams here. So if you look on the diagram on the left-hand side, you have a couple different examples of, so the triangle is the measured value. That is the value, let's say you're doing a calibration. That's what the meter is saying. So it's saying a 5, that's what that triangle is. But the circle is the true value. Now, true value you won't actually know. That's the problem here. But for the instance of this demonstration, the circle is what the true value is. If you have the, if you knew everything in the universe, there you go. You would know what that true value is. But because we don't, all we know is that triangle, the measured value. That's why we have calibrations. And then if you see the line going through that with the vertical line on either end, that is to show the measurement uncertainty. So by and large, or most commonly, measurement uncertainty is shown as a plus or minus, and then an amount. So let's say it's a temperature calibration and it's plus or minus, the measurement uncertainty is plus or minus 0.1 degrees Fahrenheit or Celsius, doesn't really matter in this instance. The measured value, let's say that is a 10. You're taking a point at 10 degrees Fahrenheit. You have an uncertainty. It could either be, you have an uncertainty of 0.1, so it could be, even though the meter is saying it's 10 degrees Fahrenheit, it could be 9.9 or 10.1. Because of that uncertainty, the equipment that you're using, the standard is, or the equipment device under test, you can only determine that it is that accurate. Okay, so that is what your measurement uncertainty is. That's the range there. So this first one, A here, that's a valid acceptance, even with the uncertainty factored in here. You're passing. So this line here, this vertical line, that is to show of essentially, let's say the standard is plus or minus 1 degree. Let's say that's what the manufacturer meter is. It's correct with plus or minus accurate to 1 degree Fahrenheit. Okay, so if you're taking the 10 degrees Fahrenheit here, that's going to be 9, or on the other side here, you would have seen a 10 or 11, sorry. So, and then you have the accuracy of the calibration standards that you're using, whatever setup you're using. Has that measurement uncertainty factored in based on your measured value. So, okay, B, you have a false acceptance. So if you see it's the measured value it looks like it's passing, right? But because we have the eyes of God, we're looking down and we can see what the actual truth is. We know that that circle, that is showing that it actually is failing. Now, again, there's no way to tell what that circle is in real life, but for the sake of this demonstration, what you're seeing is that is on the measurement uncertainty. See, so it's on the far end of it, but it could still be failing. So that's what that's showing. C here is a false rejection, the opposite of that false acceptance. The measured value is showing that it is past that point. It's reading, 11.5, right? So it is well past that false rejection, but the true value is on the other side of that line. So it would actually be passing, but you wouldn't be able to tell that because you can't tell what the true value is. That's why we're doing the calibrations. And then D is just a straight failure, just like the valid acceptance one is. It's a valid rejection, right? So on the right-hand side here, this is another expression to kind of show you what we're talking about. I probably should have started on this side. But I'm so used to reading left to right that I start on the other side. So this gives a greater demonstration of what the terms we're talking about. So you have the specification zone. That's what the specification is. Let's say the meter is rated to plus or minus, it has an accuracy of plus or minus 1 degree Fahrenheit, right? Okay, well that's you're taking it at 1 degree, it's going to -1 or +2, right? Or let's say you're taking a point at 10 degrees Fahrenheit, that's a 9, that's an 11. So it has to fit within those. But on top of that, you also have the conditional the conformance zone, this conformance zone or non-conformance zone, you have this measurement uncertainty here. That's what that factor is. And these are measure ends, measure bands, essentially, that factor that in. That's going to be the plus or minus 0.1 for your equipment. That's going to be this correct, the measurement uncertainty, sorry. Okay, so that's what that's factoring in there. It's you have conditional pass, conditional failed. If it falls anywhere in this gray area here, that could technically be a pass or it could be a fail, but you don't know because of the measurement uncertainty. That's what that additional factor is in there. If you're going past here, that's going to be a fail. That's going to be a fail. It's going to be too high or too low. But this nice little sweet spot here, that's going to be the pass. So, and even if let's say it's at the edge of this here, it's going to be a pass because of depending on how you're doing the decision rule. So, decision rule is a statement describing how you will use the measurement uncertainty in relation to the measurement results and tolerance to produce a pass-fail decision. How are you determining if it's passing or failing is essentially what that's saying. And there's a bunch of different methods, and we're going to go through some of the different options that you have here. Let me see. Oh, I got it. There we go. Okay. Yeah, there we go. Okay, so let me switch back to the spotlight. We got a couple more diagrams here to show some of the different methodologies or different statements of conformity, how you can do the statements of conformity. So this is the binary statement or simple acceptance, this one on the left here. So it has the nominal, let's say that's, that's 10 degrees Fahrenheit, right? Or 10 grams. That is the optimal. That's you have a weight that says 10 grams. You know that that is 10 grams, so that's the optimal. But you've got the different readings here. So the circle is the actual data that you're collecting. But that band here, that line with the little caps on either end, or the top and bottom, that is going to be for factoring in your measure of uncertainty, right? So it could be plus or minus 0.1. That's what that is representing. So this is obviously a pass. So you see with this line here with the U, that is the plus, and then down here that is the minus. So all right, so you have an obvious pass. That's straightforward, easy to understand. You have this one here. Now this is because you're doing simple acceptance. What does the actual data say? Not the measurement uncertainty. What is the data collected here? So you've got it's right on the line there, but it's showing it's passing. So it's because you're doing simple acceptance, a binary statement of yes, no, on, off, pass, fail, and it's simple acceptance, you're just going by what the data actually says. It's not going to factor in the uncertainty directly towards that pass or fail. Then you have this fail. It's measurement uncertainty shows that it could be a conditional pass, it could be a conditional fail, but because it's the data that you're collecting is just over that line, it's 11.2, or it's just over that line of the lower specification. It's going to be counted as a fail. And then you have the obvious ones that even with the measurement uncertainty factored in there, it's just a failure. I think that's pretty straightforward. I don't think there's going to be as little fighting on that one as the nice, easy passing ones. All right. Now, on the right-hand side, you have the a non-binary statement with the guard bands. So if you notice here that it has this lower acceptance limit, that is factoring in that uncertainty, the measurement uncertainty. So what you have is you're kind of doing a part of the simple acceptance, but you have an additional layer here. So now you have conditional passing and conditional failing. So the passing is the same as always. It's passing. It's within the upper and lower specification. It's actually even within the lower acceptance and upper acceptance lines, right? You have a conditional pass here because the data that actually is collected, it's showing it's between the lower specification and the lower acceptance limit. So it's not a pass, it is a conditional pass. It is passing on the condition that that the data collected is correct, but it's also showing in that line here the measurement uncertainty factor in there. But it's factoring that in enough where it's saying it's a pass probably. and again, this is up to a 95% expanded measurement uncertainty. So that's pretty well the standard. There are tighter ones. You can get up to 99, but we're not going to cover that right now. And then again, this one is similar, where it would just be a pass, or where that would be a fail in the other ones, it's a conditional fail because you have that measurement uncertainty. It could technically still be passing because you're reading it as failing, but you have enough unknown there, uncertainty, that it could be passing. So you're marking it as a conditional fail. And then there's just a straight fail. I think that's pretty straightforward there. And then we have the binary statement with the guard bands. So again, you're going straight pass fail. There is no conditional pass or fail, right? This is just you have the binary of yes, no, pass, fail, intolerance, out of tolerance. There is only on and off. There is no Schrodinger's cat problem here. And again, it's simple pass and the simple fail are rather obvious. I'm not going to go over those again, but where you have the difference is you have the upper acceptance and the lower acceptance limit now. Now, if it is above that, if the data point that you collected is above the lower acceptance or below the upper acceptance, if it's in with that nice passing zone, it's marked as passing. If that data point, even with the uncertainty, it could potentially be a passing, but the data point that you took is beyond that lower acceptance rate limit or the upper acceptance limit, that is going to be determined to be a failure, right? So it's kind of like the simple acceptance, but it has that extra layer with the upper acceptance limit and the lower acceptance limit there, right? So it just adds a nice little extra layer on top of that. Okay. If accepted by the customer per 7.1.3 requirements, the following decision rules can be documented. Accounting for the uncertainty will be taken to mean that at 95% confidence level, the measurement results plus and minus the expanded uncertainty, or K equals 2, as that's commonly shown, shall be totally within the specified limits. Okay, so and again, this is just a re-showing of the one of the previous diagrams, but this is a very commonly accepted statement of conformity, right? So, or method utilizing it is that binary statement with guard bands, the pass fail. You don't have the conditional pass, the conditional fail. You just have this. If it goes past that lower acceptance limit or upper acceptance limit, you know, it's pass or fail, essentially. And again, this is with the 95%. That gives you a 95% confidence level, right? Again, there are other statements of conformity or decision rules that can give you tighter ones, but 95% is pretty damn good. So just keep that in mind. Now, there is a guidance document for this. So if you are confused with this, the decision rule can be a little bit tricky. The ILAC has, and this is the international organization that is that we work with and whatnot and are a member of. ILAC has a guidance document that you freely available. You can find it online. You can just have to Google it. ILAC-G8 :09 2019 revision. It's the guidelines on decision rules and statements of conformity. This is where I think I got all those graphs from, essentially. And it goes into a lot more detail with regarding this topic. So this is a very helpful resource. I heartily recommend this for anybody who is confused by this or wants to understand more in depth. And it's a good starting point too. You can find other documents that they're referencing as well from that. But to quote them, what this this document actually governs is, this guidance document has been prepared to assist laboratories in the use of decision rules when declaring statements of conformity to a specification or standard as required by ISO/IEC 17025-2017. So again, this is specifically for 17025. And ILAC is a very well-regarded organization. Nobody's going to fight you on ILAC. Everybody's going to be like, oh, okay, it is a nice, solid organization that you're going to be able to pull from. This document provides A, overall guidance on how to select appropriate decision rules, and B, guidance in compiling the required elements of a decision rule if no standard published rules apply. So if you're not following in ASME, NIST, ISO, or other pre-established procedure or standard for that test or calibration, this is a good resource to go off of, and that's what it's designed for. It's designed to help you with that. ISO/IEC 17025/2017 recognizes that no single decision rule can address all statements of conformity across the diverse scope of testing or calibrations. So 17025 accepts that there's no perfect rule, decision rule, or that can address everything. There's just too many types of calibrations. There's too many types of tests, and everything's going to be a little different. So keep that in mind. There is no ideal one that we're using. We accept that. 17025 accepts that. Everybody's going to accept that, but you're just going to have to be able to either use the pre-existing one or determine which decision rule or statement of conformity is going to work best for whatever you're doing. And there's so much variance, I can't give you a specific on it. There is some standard ones that you can go off of, but it's, again, for very specific types of calibrations or tests. It's going to vary a lot on that. Let's see, did I go? Yeah, okay. There are testing methods that determine how the decision rules are to be applied. Now, I've mentioned this before, but this is specifically for that. An example of this, a good example, is ASTM, American Society for the, I think that's mechanical engineers. But ASTM E18 for Rockwell hardness. So this is one. This one governs hardness on the Rockwell scale. So the rules are defined in the method. So you're covered there. The decision rules effectively take uncertainty into account by utilizing repeat testing and other limits to the spread of the data. Again, this is with a lot of the ASTM or ASM. I'm going to push ASME. A lot of these have that baked into it, into their method. So you're covered there. This is then the decision rule is already baked into it, so you're safe. It covers it. It takes it all into account for you. It's baked into the cake already, so to speak. So just keep that in mind. The decision rule may already be decided for you if you're using that as the basis for your calibration or test. So, okay. Section 7.8.7, reporting of opinions and interpretations. Okay. 7.8.7.1, when opinions and interpretations are expressed, the laboratory shall ensure that only personnel authorized for the expression of opinions and interpretations release the respective statements. So, and here we'll finish this up. The laboratory shall document the basis upon which the opinions and interpretations have been made. So, one, only authorized personnel are going to give that opinion or interpretation. So again, you're going to want to have that as part of your authorization documentation. That let's say it's the lab manager is the only one that's going to give the expressions of opinions and interpretations, right? Let me plug my computer. There we go. Or it could be that you could allow for the various calibration technicians or testing technicians. It's really going to be up to you, but you have to make sure that only the personnel that are approved to authorize or are authorized to provide those are issuing those, okay? And that the laboratory shall document the basis upon which the opinions and interpretations have been made. You know, what is the basis for that interpretation? Again, that goes to the unbiased. Your interpretations and opinions are being made, they have a factual basis, and what that factual basis is, okay? And that should be on the certificate or test report. The authorization needs to be captured per, and this is, so there's another section that talks about this. Section 6.2.6, the laboratory shall authorize personnel to perform specific laboratory activities, including but not limited to the following. And section B of that is analysis of results, including statements of conformity or opinions and interpretations. So again, this is the same section, it's a slightly different subsection that governs the authorization of personnel for approving and authorizing the report themselves. So this is just another extension of that. Just reading back to that. It's an overlapping portion of that. So, but you're going to want to have some documentation, probably the same place that you're authorizing them to approve the report before it's issued, and that they're authorized to perform the calibration or test as well. It's the same kind of thing. So 7.8.7.2, the opinions and interpretations expressed in reports shall, again, shall be based on the results obtained from the tested or calibrated item and shall be clearly identified as such. So the reports shall be based on the results obtained from the test or calibration item. So you're not getting them from anywhere else. You're getting them from the calibrated device under test or the item under calibrate that you're the item that you're calibrating, right? And you're clearly identifying that you're not getting it from anywhere else, right? It is based on that data that you're getting from the calibration or the test. And 7.8.7.3, when opinions and interpretations are directly communicated by dialogue with the customer, a record of the dialogue shall be retained. So if you're giving the opinion and interpretation over the phone or verbally or in person, let's say you're at their site, you're performing the calibration or test, and you're explaining to them what the opinion or interpretation is, you're going to want to document that. Written documentation is what we're looking for. There's going to be a record of that dialogue. I mean, you could do a recording of that. That would actually work perfectly fine, I would imagine. But generally, it's going to be there after you tell them that verbally. You're going to want to write an email or have some other documentation of the information that you provided them. This is also helpful to cover your own butt if they try and claim that you never told them that or that opinion or interpretation was never explained to them. You will have some protection there because you'll be like, yes, it was. I sent you an email on the 3rd. So that is very helpful for your sake so you don't have an angry customer. But it is a requirement as well. So there you go. And then 7.8.8, amendments to the reports. So if you're revising or amending the reports, that's what this section is going to cover. 7.8.8.1, I think I got that right. When an issued report needs to be changed, amended, or reissued, any change of information shall be clearly identified and, again, where appropriate. So where appropriate, the reasons for the change included in the report. So this could be anything from, I forgot a 0 in their serial number, so I have to revise that. Or a lot of times it's something stupid, something simple that you just did a typo. It could be any number of things. If you've already issued the report, then you're going to have to reissue it or amend it or change it, and you're going to have to mark it that it has been changed. And it's clearly identified that it has been changed. And again, where appropriate, the reason for the change is included in the report. If there's a typo, you can generally get away with that as long as you're noting what you've changed. If it's something more serious or more extensive, you're probably going to want to explain why you're making that change or why that change is necessary. This could be as simple as the client requested it. That covers you for if the reason for the change or the revision is because the client found an error, they want you to fix it. You're covered there. All right. Or you use the wrong form or something other, simple like that. You're good. So section 7.8.8.2, 7.8.8.2, yeah. Amendments to a report after issue shall be made only in the form of a further document or data transfer, which includes the statement, amendment to report, serial number, or as otherwise identified, or an equivalent form of wording. Such documents shall meet all requirements of this document. So what this means is, if you're amending the report, you're going to have a different, some indication that it has been revised. Either the naming of the document itself, it's the digital version of it. There's going to be a stamp that says revised or amended or something like that. Something along those lines. That is going to show that that report is, or you're going to have a statement on there that says, this report has been amended per blah, 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 blah. Or it could be an entirely new document that's going to have, let's say you're issuing a new calibration certificate rather than revising it. It's going to have, you're going to want a statement on there saying that this report is an amended version of, and then the old report number on there. So, and again, they shall meet the requirements of this document. So they still need to meet all the requirements that we've previously gone over. It still needs to meet all those. So that's just, covering that base there. Okay. 7.8.8.3, when it is necessary to issue a complete new report, this shall be uniquely identified and shall contain a reference to the original that it replaces. So again, let's say there's any number of ways that you could do this. Some of the examples are, you have a certificate number or a test report number. You add an AR at the end of it. You add a revision 1, revision 2, revision 3, etc. as necessary. You have the date it was revised. That's another good one. Or test report replaces and then the old certificate number, right? So the important part is that you're going to have the old report, you're going to have the new report, and they're going to be clearly identified as two separate documents. There's to avoid that confusion. This is the unambiguously requirement that we stated at the beginning there. That's what this is trying to control for. So keep that in mind. Okay, and that is it. Now, thank you for listening to my ramblings. I hope I didn't speak too fast or any of the rest of it. I'm still relatively new to this, but we have some time allocated for questions. You should, I can check what has been submitted, if there's been any. Let's see, I don't think there's been any submit. Oh no, let me pop this out into its own little window here. Okay, so we do have some questions. This is good. And again, I may skip your question if it is outside of the scope of this webinar. I may also, if it's something simple, I may also decide to answer it. But if the question is not answered, feel free to send that question via email directly to webinar@pjlabs.com. So anybody who doesn't get their answers answered or addressed, feel free to send it there. It will get passed on to either myself or somebody else at PJLA Labs, and we'll be able to work with you there. So, okay, let's start at the start here. Okay, so okay, how do the companies do this in a SAP environment? The lab does testing results in LIMS, which transfer to SAP, which generates a report. This lab is part of a larger organization. I don't know what specific part you're referring to, just because it's, there. So I don't know. Okay. So yeah, so I don't know what you're entirely referring, what portion of it you're referring to, just because the question is worded probably during that part of it. So let's see, I'll just move on. Yeah, so I'm not super familiar with what SAP environment is referring to. So I'm unable to answer that. I'm sorry. Looks like that is a duplicate of that. Okay, somebody left the audio. Okay. Okay, so here's one. How do we ensure objectivity of the test results? What are the risks we should keep in mind and how to prevent them? If the laboratory is really small, 4-person lab or less, how do you measure these risks and track them? How do you often to update? And again, this is going to vary a lot on the individual type of test that you're performing and the rest of it. Part of it is you're going to be training them and drilling it into their heads of the impartiality. So that's going to take place. A lot of that is an objectivity. A lot of it is going to be straight. You know, if the number is less than or more than the amount, it's pretty straightforward. At a certain point, it's going to be trust, but the main answer to that is going to be training and training really, making sure that, and trustworthiness. You're going to know your people. They're going to be trained to be able to perform the tasks, and just oversight. Training and oversight is really how you're going to address that. And it's really going to depend on who you're doing and what testing and calibration you're performing. How you measure and track the risks, it's going to be up to you. It's going to be an individual lab, but again, the most common answer is going to be training and oversight. So it's going to be how you organize it and how you do your training. Okay, can you give examples of the valid reasons for 7.8.2.1? Let me pull up that section. Okay, 7.8.2.1. Just so I have that in front of me. Okay. Examples of valid reasons. 7.8. Yeah, 7.8.2.1 is that's the section that lists the entire requirements for all of them. So it's going to be one of those of, if you look at any calibration certificate, any test report, it's going to have all of those items on there. I can't give you an example of valid reasons for not doing so. Okay. So I mean, like, again, it's going to vary a lot on which particular section you're talking about. So let's say identification of the method used. No, that's not a great one. Identification of the method used. Let's say you're just following the procedure. You're going to list that procedure that you're following. If it's an internal method, that's going to be enough of it. But anything like the most of these you're going to want to require it. So let's say section N, additions or deviations, exclusion of the method. If you're not deviating from the method, you don't have to include any deviations of it. So you're going to cover there. That's really it. If you have a valid reason for not doing so, it's going to be really dependent upon the individual lab, the individual test, and the individual calibration. The main thing is that you're going to have to be able to justify that to an assessor or auditor when they come through. It's going to be really dependent upon the individual thing that you're doing. So some of those requirements that are listed there are going to be specifically for test sampling, like that. You can, if you're doing calibration and you're not doing any sampling, you don't have to worry about those. But it's going to be really dependent on the individual lab or test or calibration. Okay, in environmental sampling and drinking water work, some procedures are done in the field, i.e. pH and residual chlorine. The report says the site of collecting the samples, but we never specifically say on the report that these are measured in the field. Is this an issue? It depends on how you're wording it. You might have a statement on your test report that says, these parts of it were done in the field. If the method is stating that these are being performed, you're probably going to be covered. But again, it's going to be kind of dependent on it. I would imagine, yeah, pH. I've had to do that for your pool or whatever. and chlorine testing, you're just going to be doing it there. It's really going to depend. You should be safe not listing it like that, but you might get an assessor or auditor might make you add that on there. It's going to really depend on them and whether you can defend that, not including that. I could see it either way, but you might be safer to have a statement saying that portions of this were performed out there. And I think there's a requirement of that. Oh, here you go. Here's the reason why you could get around that. What you can use it for, where this is relevant to the validity or application of the results. So, is that going to affect the results? Probably not. So you're probably good. Where the sampling plan or sampling method, or where that's going to be. So you might have some exemption with that, but again, it's going to depend a lot on the assessor and how you're going to defend that. So let's see. Okay, that's okay. I had the problem with the end of the. Yeah. Yeah. So somebody else is already stating that they had that problem with the end of the report, an end of the report statement. Again, it's less of an issue if it's a single page one, but again, the easiest method for that is you just have a page count at the bottom, like page 1 of 2, page 3 of 5. That's going to be your easiest way to point to. But it's an easy one for assessors to catch you on. So just be careful with that. Okay. When we send out a sample to be analyzed at another 17025 lab, we sometimes take the results from the lab and incorporate them into our reports, with a clear indication that the results are from another lab. And that is the important part. You have to have that clear indication that they are. Would this be a contravention of the subcontract lab statement about shall not be reproduced in full without approval? You are the one issuing the report, so you're fine with that. You're going to want to. It may be an issue for the outside laboratory. You might want to talk to the that third-party laboratory that you're dealing with to make sure that they are aware of it. But odds are they're not going to fight you on that, because what you're doing is you're incorporating the information there. You have the information necessary. You're not presenting it as its own document, and you are presenting it as portions taken from the other one. As long as you're maintaining the record of the original, the third-party certificate or test report, you're probably safe. You should be fine. I wouldn't worry too much about that one. That's going to be less of a thing, but you best practice to talk to the third-party lab that you're utilizing to make sure that they're aware of it. So, okay. Customer sends instruments for calibration. I don't know what that. Okay. I don't know what that question's for. Yeah, so if you have as received in your notes of your report or whatnot, and as calibrated on the test reports, or as received, that is acceptable for the what is it? The state of the equipment that you're receiving. So that is perfectly acceptable for it to have that statement. That is, you're well within what you're looking for. Interpretations is in normal conditions where interpretations is not requested, information on environmental conditions are not necessary to be reported. So the environmental conditions are, oh, they've already left. We'll answer it just for anybody else as well. So environmental conditions are not necessary to be reported if they are not going to affect the results. So again, almost everything is going to, temperature and humidity is the standard, but and you may have additional ones needed, but it is going to be very dependent on whether that's going to affect the results or your interpretation of the results, the pass, fail, etc., whether that's going to be a factor in that. So yes, That could be a factor, that could not be a factor. It's going to vary, be dependent on the test or calibration that you're performing. Okay, just yeah. The conditions while being calibrated is what you're looking for. That's a continuation of a previous question there. So if you've got, as received, you're covered there. If it's like a calibration, something that you're doing, but or like a device under test, what that's covering for you is if it's damaged in shipping, it was working when you received it, is what you're basically doing. You're covering you're covering your lab as well. And it's also just as a statement that you did inspect that to make sure that it was actually functional and working and you didn't notice any damage. So it's covering you there as well. So calibration reports shall identify the accuracy of the calibration standard and the uncertainty limits. Also, A has found as left conditions of the MTE. I don't know what that question is regarding, since it's a statement rather than a question. Yeah, the accuracy, the measurement uncertainty is what you're looking for. The accuracy is oftentimes confused with the measurement uncertainty because the accuracy is going to be a part of that. It's going to be a factor into that, the data that you're taking. So 7821C. Okay. Okay. If the calibration is done at the customer site on a mobile van, does it need to be stated on the certificate as the main site or the mobile number? So that is specifically regarding C. You would put the mobile number. You would still have your name and address of your primary laboratory, because that is essentially your company, like who is performing the calibration, and then you would have some statement saying that the calibration or test was performed in the mobile lab, and then you would have that mobile lab number, whatever. How do I put this? However you're defining that as. So, I mean, I've seen some where they have the VIN number for the van that they're using for the mobile lab. But yes, you would want to have that. It was performed, at the customer's location and using the mobile lab. You want to have some statement of that effect. So, yes. Okay, when performing internal equipment calibration / intercomparison, should we also satisfy conditions such as atmospheric pressure, temperature, and humidity? For instance, the volumetric glass, even if we are not laboratory for calibration. This entire section is only for test reports, calibration reports, etc. So if you're doing something outside of that, such as interlaboratory comparison, you have some wiggle room. If you're not issuing a calibration report under your 17025 program, you're safe. If you're doing some internal work, you're safe. You don't necessarily have to be following all of this for your internal testing and that. You can do testing and calibrations outside of your 17025 program. So that could include your internal equipment calibration or comparison. It's going to depend. If you're doing an internal calibration under your 17025 accreditation program, then yes, you are going to meet that in the calibration report that you are issuing. Even if you're only issuing that to yourself, you still want to include that, because that's going to depend on whether for the environmental conditions, whether that is going to affect that calibration or test. So it's going to be very dependent upon that individual test. So if you're doing it for a client, you're going to want to do it for yourself. It's just good practice there. But again, you do have some wiggle room if you're not issuing it as an official calibration certificate or test report, if it's more an internal document or test that you're performing. So Can we use customers ask laboratories for statements of conformity, and how should we write the request? For example, regarding a thermometer, can we as customers ask the laboratories for statements of conformity, and how should we write the request? Example, oh, this is repeated twice. Sorry about that. So what you would do is this would probably be best written into the quote or purchase order that you're issuing out to the other lab. For like a thermometer, it'd be like, we want an ISO 17025 accredited calibration with the following, with a pass-fail, statement of pass-fail or intolerance out of tolerance for each individual point. It's something as simple as that. It's really what you want. You're just going to have to come to an understanding between you and your the outside laboratory that you're utilizing. But you can write that in there. Probably the best way, the most official way would be to have that in your quote or purchase order or whatever other document that you're utilizing for those purposes. But you could have something more informal, preferably like an email. Something written is generally going to cover your base the best way because it's written, obviously. And so you have something to hold up if they argue with you about that, of what you wanted. Okay. There are no stupid questions here, so don't feel bad about asking it. But do we have an SOP for sampling if we are not performing it and are not accredited? Okay, yeah. There was a nonconformity noted 1 year ago on the accreditation body. Do you need a statement of policy for sampling if you are not performing it or not accredited for it? No, but you might want to include a statement in your procedures that sampling is not performed by you, either in your procedures or your quality manual or somewhere. That is best practice, but it is not. I probably wouldn't find that as a non-conformance, but again, best practice of your scope. Because you should be able to point to your scope of accreditation, say we performed those kind of calibrations or tests. That's how I would argue it, is just literally pointing to your scope of accreditation. If you have a statement in your quality manual or procedures saying that pointing to that, that would also cover you. Saying that this basically you're going to have a scope in your quality manual or one of your procedures saying that these apply to any test or calibration of which we are accredited under 17025 or other organization, or accredited or certified, etc. So that's a borderline. I don't know why they would give you non-conformance for that one. That seems a little bit harsh, but yeah, best practice is to mention it somewhere. Should the calibration report always contain the TUR values? Let's see. Let's see, the TUR values. What is that? Oh, test uncertainty ratio. Okay, yeah. So there's a couple different ways you can do measurement uncertainty. TUR is one of them. It really is going to depend on how you are utilizing and applying that. So measurement uncertainty can be done in a number of different ways. You're going to have to always show what the uncertainty is. That is a requirement for calibration. But how you do that, there are a bunch of different ways that you can do that. So there is no one path. It's kind of like with the measurement, the decision rule and the reporting results there. So okay, laboratories engaged in calibration work in our country generally do not provide a pass/fail statement on the calibration certificate. Instead, they give the results that are open for interpretation. They provide results and measurement uncertainty. That's it. Do we set the criteria by which the device will pass or fail based on which the laboratory will declare a pass/fail, or are we obliged to obligated to provide these statements themselves. Statements themselves. Since they do not provide the statements, can you recommend some standards according to which we can set these criteria and evaluate whether the instrument has passed calibration or not? Doing a simple acceptance is, again, the decision rule is, there's 1,001 different decision rules and how you do that. The main factor that you are going to need to do is factor in your measurement uncertainty. That is one of the key things. Keep that in mind. If you are doing simple acceptance, or even just provide, if the client wants just the data and they don't want a pass-fail statement, that is acceptable. You just need to have that the client is okay with that, right? So that's perfectly fine if they just want the raw data and you're not giving a decision rule, a statement of conformity. That is okay, as long as, again, the client is okay with that. So that's going to be the bigger thing. But that's going to be dependent on you talking with the client, and depending on which standard you're using or what specification. If you're following a specification or standard that requires that or has that baked into that, then you're going to want to include that. But again, a lot of this can be excluded if the client wants you to. So, I believe that ILAC document that I referenced before gives a lot of guidance on that, as well as I think there was a ISO document as well referenced in there. And again, these slides for these are going to be provided or available on our website. So if you're looking for that. Okay, thank you. It's really one of those reporting of opinions and interpretation of the results. Can a laboratory for testing say that they do not provide reporting on opinions or interpretation of the results? It's going to be more what you and the client want. If you're giving us very straight, here's the raw data. If you have the agreement of the client and that's what they want, you're good. You're set. The decision rule, again, there's not a specific decision rule that you have to conform to. There's a lot of wiggle room there. I again will direct you to the ILAC document that I referenced previously in the presentation, the webinar. Okay, what if the ASTM or ASME does not clearly state the tolerance use for the pass/fail decision? If it's not baked into that, then it's up to you and the client to determine, for you to determine what you want that pass-fail decision rule to be. So that's going to be, if it's not baked into it, then it's just that there are a lot of those that have that already baked into that. That's why that was continually repeated. But some of them don't, and some of them you'll want to determine that, and you'll just want to determine what's best for that test or calibration, and then also the client may have a preference as well. So they may request a specific, pass-fail or just the raw data. Some of them do want that. So it's going to vary a lot. So for the TNI compliance, can calibrations be done either with NIST traceable or ISO 17025, or do both work for that standard? So what you're going to want for that, and maybe I didn't explain that as clearly as I probably should have. I'll have to revise this for the next time. If you're sending your calibrations to an ISO 17025 lab, they are required to be traceable to the SI. And if they're in the US, traceable to the SI through NIST is the standard, how that's termed, NIST traceable. We're trying to get away from that language, but so you're safe if you're sending it to a 17025 accredited laboratory. You're safe, okay? Now, the reason why it's written like that is occasionally certain methods of calibration or testing, I suppose, they don't have a lot of labs, and so you might have to use a lab that is not accredited. If that is the case, you're going to have to ensure that it is traceable to NIST or to another 17025 calibration lab. If they are, generally that'll be documented on that lab, but you're going to want to be able to trace that through. So you are safe if it's an ISO 17025 calibration lab that you are sending your equipment to for calibration. So that covers that NIST traceability ideally, and unless they're doing something wrong, or that traceability to the SI. Okay. Is it imperative that a named person is part of the address to the company you are performing the calibration on the certificate, or just the company name? The company name is what you're looking for, and then the address. So the company and the address. You do not need an individual name. You will need the individual performing the calibration and authorizing the issue, reviewing it, authorizing the issuing of the report. Those are the names that you're going to need. So the name of the company that is performing the calibration, the name of the client that you're sending the calibration to, and and then the person performing the calibration, and then the person authorizing the report itself. So those will all need to be included on there, but you will not need the name of the person, the company that you're performing the test for. Just the name of the company. If a calibration result is expressed in bar, so I'm assuming this is pressure, but the uncertainty is in PSI, is this acceptable? It should be, the measurement uncertainty should be in bar as well. So you're going to want that in the same unit of measurement. There is a requirement for that, unless there is some weird extenuating circumstance. For pressure, I don't think there would be anyone. You're just going to have to convert the measurement uncertainty over into that unit of measurement. So yeah, that would be required. Okay. Okay, looks like we got somebody from Albania just saying thank you. So thank you for showing up. I appreciate the international attendees. For a testing lab, would it only be applicable to present measurements of uncertainty on the report if the decision rule is being employed takes them into account? Or can you give an example of a relevant, when this is relevant, section 7.8.3.1. Okay, so let me pull up that one. Okay. Now I am not as super familiar with the testing lab. I'm again a calibration program specialist, but it is rare that the measurement uncertainty applies to the testing side of it. Okay, it is going to be very dependent on the specific type of test. I can't think of one off the top of my head, but most of them aren't going to need the measurement uncertainty. So it's more common than not that you're not going to have the measurement uncertainty included for a test report. So that's going to be the answer to that is 9 times out of 10, it's not going to apply. So, but there are occasions where it could apply, but they are. I can't think of one offhand. I'm not super familiar with the testing side. So, okay, and we got another person from Serbia, so that is always appreciated. And I think we are at the end of the questions. So, again, thank you all for attending this. Let me close this down for attending this webinar. And one last thing before you all leave. So we also have another free live workshop through PJLA, and again, you can find this on our website in our training section. It is approaches to competence of personnel being performed by Matthew Sika, and I believe this is also virtual. So international ones, you have this available to you as well, and that is on October 15th of this year. From 1 to 3 Eastern Standard Time. So be sure to check that out. We try and do at least one of these webinars a month or more. So keep an eye out. And if you have a particular topic that you're looking for, keep in mind all of our old ones are posted on our website as well as our YouTube channel. So there are a plethora of some older webinars that you might be able to reference as well. So just keep that in mind. Okay, and everybody, I hope you have a lovely rest of your week. And yeah, I think that's it for us. Bye.